Welcome to Blood Sugar Squad, your go-to channel for simple, actionable tips to manage diabetes and live your best life. Microscopic pieces of plastic are circulating in your bloodstream right now. They are in your food, your water, and even the air you breathe. Emerging research suggests they may be quietly making insulin resistance worse. This is not speculation. Multiple recent studies have found that people with diabetes carry significantly higher levels of microplastics in their blood, with a measurable correlation to A1C, the same marker used to track long-term blood sugar control. So what exactly are microplastics? How do they get into your body? And more importantly, what can you actually do about it? In this video, we will break it down in 3 parts: what microplastics are and how you are exposed, what the latest research says about their link to blood sugar and metabolic health, and practical, evidence-based ways to reduce your exposure without turning your life upside down. Segment 1. The science of microplastics. Microplastics are tiny plastic particles smaller than 5 millimeters. That's about the size of a sesame seed or smaller, and often invisible to the naked eye. Some are manufactured that way, like the microbeads once used in cosmetics. In fact, the concern over these tiny beads washing down our drains and into the water supply was significant enough that the U.S. Congress passed the Microbead-Free Waters Act back in 2015, which officially banned the manufacturing and distribution of rinse-off cosmetics containing plastic microbeads. Others form when everyday items like water bottles, food containers, and synthetic fabrics break down over time. Once released, they don't disappear. They accumulate in our water, soil, and air, and from there, they enter the human body primarily through ingestion and inhalation. That means when you drink from plastic, eat food stored or heated in plastic, or even breathe indoor air filled with synthetic fibers, you are being exposed. Microplastics have now been detected in human blood, lung tissue, breast milk, and even the placenta. This is where things start to matter for blood sugar. Microplastics themselves, and the chemicals they carry, can interfere with hormone signaling, and insulin is one of the most critical hormones in your body. Segment 2. What the data actually shows. Emerging research suggests several ways that microplastic ingestion may contribute to insulin resistance. They can increase oxidative stress, which damages cells and makes them less responsive to insulin. They may disrupt mitochondrial function, reducing your cell's ability to use energy properly. Some studies also show damage to pancreatic beta cells, which are responsible for producing insulin. And finally, microplastics can alter the gut microbiome, promoting chronic inflammation, which is one of the key drivers of metabolic dysfunction. Small human studies have begun to test this directly by measuring microplastic levels in the blood. What they consistently find is that individuals with diabetes tend to have higher levels than healthy controls, along with positive correlations to markers like A1C and fasting glucose. In simple terms, higher microplastic exposure is associated with worse blood sugar control. Researchers caution that this does not prove causation, but it raises an important question. Are microplastics contributing to the problem, rather than just showing up alongside it? Animal studies help fill in some of the gaps. In one experiment, piglets exposed to PT microplastics, the kind used in water bottles, developed elevated insulin levels and metabolic changes consistent with early insulin resistance. These effects were dose-dependent, meaning the more exposure, the stronger the disruption. While animal models do not always translate perfectly to humans, they provide important clues about what may be happening inside the body. Researchers have also proposed a mechanism involving the gut-liver axis. Microplastics may weaken the intestinal barrier, allowing bacteria and toxins to enter the bloodstream. This can trigger immune responses that increase inflammation in the liver, which then feeds into systemic insulin resistance and metabolic dysfunction. The evidence is growing, but here is the honest bottom line. We still do not have large, long-term human trials proving that microplastics directly cause insulin resistance or that reducing exposure will reverse it. Most of the data comes from animal studies and observational research. But the mechanisms are biologically plausible, the patterns are consistent, and from a risk perspective, this is not something to ignore. Now, while the science on microplastics is still emerging, one thing is already clear. What you eat every day has a direct and measurable impact on your blood sugar. That is why we created the free Blood Sugar Squad Mindful Eating Guide. It is designed to help you build a healthier relationship with food, without extreme diets, complicated rules, or fear about what is in your environment. Just use the QR code on screen or the link in the description below. Segment 3, what you can do. So microplastics are everywhere, and they may be affecting your metabolic health. What can you actually do about it? The good news is, you do not need extreme changes. A few practical adjustments can significantly reduce your exposure. Start with water. Bottled water has been shown in some studies to contain very high levels of microplastics, sometimes even more than tap water. Switching to filtered tap water and using a glass or stainless steel bottle is one of the simplest ways to cut exposure. Filters like activated carbon or reverse osmosis can further reduce contaminants. Next, focus on how you handle food. Avoid heating food in plastic, especially in the microwave, where heat can accelerate the breakdown of materials and increase chemical leaching. Use glass or ceramic instead. The same goes for storage. Switching from plastic containers to glass is a simple long-term upgrade. In the kitchen, small choices add up. Plastic cutting boards and utensils can shed particles over time, while non-stick cookware may introduce other chemical exposures when damaged or overheated. Alternatives like wood, stainless steel, cast iron, or ceramic reduce that risk without adding complexity to your routine. Air exposure matters too. Synthetic fabrics release microscopic fibers that can become airborne and inhaled. You cannot eliminate this entirely, but you can reduce it. Using a HEPA air filter, vacuuming regularly, and capturing fibers during laundry are all practical steps that make a difference over time. Finally, your food choices can help lower overall exposure. Highly processed foods tend to involve more plastic packaging, while whole foods generally involve less contact. That shift not only reduces potential microplastic intake, it also supports better blood sugar control. The reality is, you're not going to eliminate microplastics completely. They are already in the environment. The goal is not perfection, it is reduction. Think of it like sun exposure. You cannot avoid it entirely, but you can limit unnecessary risk. The same principle applies here. Segment 4, final thoughts. The research on microplastics and insulin sensitivity is still emerging, but multiple lines of evidence point in the same direction. People with diabetes tend to have higher microplastic levels. Animal and lab studies show effects like inflammation and cellular stress, and the biological mechanisms are plausible. Taken together, it is enough to take seriously, even if the science is not fully settled. That is where the precautionary approach makes sense. You do not need perfect evidence to make practical changes. Simple steps like switching away from plastic bottles, avoiding heating food in plastic, and choosing glass when possible are low-cost, low-effort decisions that may reduce exposure, while also supporting better overall habits. Many of these changes already align with good diabetes management, eating less processed food, cooking more at home, and being more intentional about what you consume. You are reinforcing behaviors that already support stable blood sugar. You cannot eliminate microplastics entirely, but you can reduce your exposure over time, and that is what matters. What are your thoughts about microplastics? Comment below, and please share this video. Until next time, stay strong, stay sweet, but not too sweet, and keep thriving with the Blood Sugar Squad.